everybody, right in time right there. I was getting everything set up. I was like, oh god, we gotta get this going. We gotta click on it. Good to see you here, Bailey. Good to see you here, Ryan. Good to see you here, Lauren. Everybody, how is everyone doing? We got the music playing in the background. We got the Kahoot music, but we don't have disco yet. So I failed you. We didn't have disco music going, so this is the Kahoot disco music in 3, 2, 1. A run button. I'll learn how to click the buttons here eventually. Are these videos upload after? You bet. These videos are live afterwards. Kahoot code is up. Time to join in the Kahoot. We got some big announcements. Stats 101, your test is Tuesday, 6 p.m. to 11 p.m. Eastern Standard Time. And with that, we know where the review site is. The review site is the Stats 101 site. Kahoot Disco, definitely there, Ryan. Stats 1, Mubot, why don't you tell us where the Stats 101 site is? And some good news, we're playing for 2 prizes today, $20 first prize, $10 second prize, and we have 320 and 201 competing. 201 might have a little bit of an edge because they've already covered regression, but 320, their whole class is called a regression. Lots of helpful hints, lots of review today. If you didn't know it, Alyssa Gordon, right? Hopefully I pronounced her name correctly. She is our SI coordinator for 201, and she will be holding a review Sunday at 2 p.m. And I'm going to try to do a review live on YouTube after that and the Kahoot. Now, who knows what the prizes are for the big Stats 101 Kahoot Sunday night at 7 p.m. I'm doing it at 7? I think I'm doing it at 7. Who knows what the prize is for the big Stats 101 Kahoot? The F statistic, that is the ratio of the observed over the expected. Really, do I have the slider for that still? Let me pull up the slides for it. $50. Oh my gosh, just craziness right there. $50 for first prize on Sunday night. Sunday, oh, Sunday only. $50. The F statistic, really good. I'm going to bring up a really good interpretation on this. So give me 2 seconds as we listen to some Kahoot Disco and get ready. We'll get started here in 3 minutes. That's a 1 minute timer. The F statistic is basically like how much more, in terms of multiples, how much more variation between the groups was there than we would have expected due to random chance. So the F statistic is a ratio, and that's a big important thing to remember. I think the notes are a huge help on it. So let's go here to the F statistic notes. When we interpret the F statistic. So here we go. F statistic interpretation is going to be all the way down here at the end. And here we go. There we go. This is some key interpretation right here. I'm going to go look at the screen while everyone's signing up for the Kahoot. Oh, you can see it right there. So there it is, a little bit bigger, but some key interpretation right there on the F statistic. Definitely review the between group and the within group variation and what it means to have a certain F statistic. Key important notes right here. Don't worry too much about the permutations. Timers. 2 minute timer. We'll get started in 2 minutes. It's a 1 minute timer. Hop back to space right here. And hop back to the Kahoot. 22 people in the Kahoot. Can we break 30? Yep, sorry. Kahoot code is on the screen again now. Kahoot code is on the screen. Does that, can you, yeah, I can't breaking it. Oh, that's all right, Adam. That's all right, Adam. It's from the previous, I think that's why it's confusing. Don't die. Don't die. No one die. What's up, Lucy? Didn't see you there. I'm looking through the comments. I was looking at everything right there. Good to see you here, Lucy. We got some 320s and 201s. Who's going to win, 320 or 201? What's the bets on right now? Let's do a bet. Let's have Mubot come up here and bet. So let's go ahead and get some betting going. Or let's do polls. I can't do a bet. You could bet your points. Should we do a bet or a vote? I don't know if I should have Mubot like have a bet go that long. And I could pick the winner at the end. Should we bet or vote on it? I don't know what happens if I have a bet go the whole time. Should we bet or vote on who's going to win? Is there a difference between dying? Okay, we're going to vote. The first one is vote. So let's do a poll. Who will win? So we have option 0 is 201. And option 1 is 320. So let's take a vote right here. Who's going to win? 201 or 320? Marcus does the vote on it. So vote 0, exclamation mark, vote 0 for 201, exclamation mark, vote 1. Who's going to win? Time's running out to join. Make sure to join. We got 26 seconds left to join. 201's getting a lot of votes. 320. You're losing out here. We got 11 to 4 votes. I don't know. 320's got a little bit of advantage. Roderick's voting for Rodin for some 320 right there. Sounds like we're about to start Kahooting here. Or it just keeps getting longer. We'll stop the vote right here and join in. That's the timer. Well, it's a vote, so there's no picking the winner. I don't pick the winner when we vote on stuff. With this, 2 seconds right here. Let me make sure I got everything up and going. One moment, everybody. Okay, got that. Boom. We got 30. Wait, we had 30. We're starting here in 5 seconds. Join in now to start. What happened? We're starting in 5 seconds. 5, 4, 3, 2, 1. I don't know what 2 is. 1. Here we go. Let's go. All right, let's go to the main screen. This week we're covering regression and correlation. And let's see what everyone knows. What is the strength of the following scatter plot? Now, scatter plots show a strength, direction, form, and unusual features. Strength, direction, form, and unusual features. There should be some of these that jump out to you immediately. Hopefully everyone gets this one correct. You should instantaneously know the direction of this is what? 30 answers? That should be everyone, right? The direction of this is what? Chat, help me out. What is the direction of this? What is the direction of this scatter plot? There's 2 directions. Negative. Nice job right there, Lucy. It is negative, and this is definitely negative. Yes. So some people thought it was water than it is. Some people thought it was a little water. Water. So people thought this would be moderate weak, I'd say. This is moderate weak, and this is moderate strong. So the weaker it is, the more spread out it's going to be. And a student showed me a long time ago that if you go around your scatter plot, like if you take a scatter plot and you were to draw around it, it's doing that thing again. That thing it does. If you take a scatter plot, sorry, and you draw around it, if it makes a circle, it's closer to a 0. If you make a 1, it's closer to a 1. But we should know things like this, plots like this, have a correlation equal to about what? Plots like this, down here at the bottom, I'll highlight it. Plots like this also make a 0, so they have a correlation that's closer to what? What is their correlation, a plot like this? Correlation close to 0. But the thing is, it does not have a correlation because correlation only measures what strength? What strength does correlation measure, especially for 320, Pearson correlation? Pearson correlation only measures what strength? Linear strength. And Kiana's right. This is great job, Kiana, right there. This is very strong. It's just not linear. It's a strong parabolic form. So is that bottom graphic there associated? Does that bottom graphic down there have an association, yes or no? That bottom graphic has an association, yes or no? Does that bottom graphic have an association? This bottom graphic down here, does it have an association? Yes. And Pearson needs linear. So this bottom graphic does have an association. It has a parabolic association. So it's a different type of form than the linear that Pearson looks for. So there's a parabolic association. This definitely has an association on the bottom. Let's see who's in the lead here. Remember that review I just did right there? We got Cheerful Deer in the lead, but you know what? Who would not want an agile pony growing up? That just sounds awesome. Like, I own an agile pony. But yeah, we're going for or Bronze Owl. Those are my 2 favorites right now. Sorry, everyone else. Those are my 2 favorite, Agile Pony and Bronze Owl. And you're in 4th and 5th. We're rooting for you right there. Nice job, Lucy. Great notes in the chat. Lucy's put some amazing notes right there. Check out those notes. What is the strength of the following correlation? Shocker, right? What is the strength of the following correlation? So you need to look at it and say, is it strong? Is it weak? Is it negative? Is it positive? Is it linear? Is it not linear? And I just mentioned the direction, the form, and the strength. So form, at least for 201, is linear, not linear. So linear, not linear. In 320, our nonlinear stuff could be monotonic or not monotonic. I don't know how to do not monotonic. There we go. Parabola. That's not monotonic. Yes. What did you look for immediately when you were looking at answers? You looked for a what? What did you look for immediately when I said, what is the strength of this correlation? You immediately, your eyes thought, I need to look for a what? 0. Like you thought I should find something close to 0. It doesn't matter if it's negative or positive, really. It's going to be very close to 0. So since it's not really well described by a line, the Pearson correlation, also Spearman for 320, Spearman would be close to 0 too, because it's not well described by a monotonic rank-based relationship. We don't really have much this covers like some 320 stuff. So 320, I'm very interested who's going to win. So weak because not linear. Exactly. It's not well described by a linear relationship. Let's see who's in the lead. Remember the review. Oh, my Agile Pony. I knew it. Bronze Owl, you'll still come back right here. But Joyful Seal, you're my new favorite. Joyful Seal, I'm rooting for you, Joyful Seal. You got this. Let's find out the next question. Maybe it's something we've heard. True or false? The following scatter plot has no association. Is that true or false? The following scatter plot has no association. Malls of Heron is true or false is that I selected the wrong one. I reviewed this before I put it up. How could I make 2 mistakes? Impossible, right? Impossible for Brian to make 2 mistakes. Brian never makes mistakes. There's a review question right now. The answer is most definitely false. Nice. What does that mean? It has an... Can anyone describe? I don't want to say it. I want you to say it. I want you to put it in the chat. Oh, we need... Puppet Shark, did you get that right there? Did you get it? Puppet Shark, your counter needs to be on. Let's go over here to the counter. We've started the yeah counter. Yeah counter is on. How many times has Puppet Shark said yeah this semester? Knowing X gives you... Yeah, Lauren, great job on the 320 interpretation. Mewbot is always live. He's always alive. Mewbot, you doing all right, Mewbot? You doing good, Mewbot? You good? Oh my God, the boss. Everyone's here. Everyone's here. It's like Smash Bros. Let's go back over. This is too much. It's too much. The boss is there. Everyone's there. There is a non-linear association between X and Y. Amazing answers, everybody. Look at all these amazing answers right here. It has a strong association, but almost no correlation. Exactly, Jensen. Amazing answer, Jensen. You are right. There's no linear correlation, as you're saying, because, and this is kind of a review of what we were doing, in this sort of plot right here, there is no, you need, oh,
I am Mewbot.
He's here. He's here. There is no linear association. We have right here a non-linear parabolic association. So the correlation of this one and this one are both 0. So let's just put a note on that the R for this one is 0 and the R for this one is 0. But this one has an association where the top one does not. So this one has some sort of association and the top one has no association. This is your perfect example of no association. He's doing all right. He's been Mewbotting it up lately. I don't know what Mewbots do, but he's been doing his thing. Who's in the lead? Oh, look at this excited Wildcat on the leaderboard again. Great job. Look, Diplomatic Hen. This is your game right here, Diplomatic Hen. You got this. Let's see who's going to win next here. Which of the following is required to make a scatter plot? So scatter plots. Now, everyone knows my famous QQ, straight enough, no outliers, plot doesn't thicken. That kind of gives away the answers. Everyone knows that. You know what? We got a quote now. Because everyone knows that. Quote 57. Everyone knows QQ, straight enough, no outliers, plot doesn't thicken. I think it's quote 57. So it gives away the answer. Is it the right quote? Mewbot, you are a little slow, and I don't know why you slowed down so much. You were right. This baby knows statistics. QQ. What does QQ mean? When we talk about QQ, so maybe you're not in my class, that's all right. I forget. I'm just kidding. But people sometimes like, Brian, what the heck are you talking about? QQ, straight enough, no outliers, plot doesn't thicken. So when we talk about QQ, we might have a relationship here between like how long you study for the test and your grade on the test. So what does QQ mean? Everyone help everyone out with QQ. So this is what's required to make a scatter plot. It's required that it be 2 quantitative variables. So what is required? What is this? Well, I just kind of said it. What does this mean? This is our review right here of the conditions. The more you say them, the more you practice them, they just get ingrained in your head. And you're like, QQ means that what about these variables? 2 quantitative variables, exactly high right there. Great answer. 2 quantitative variables, Kayla, great job. And then we have what? That the relationship between the variables must be straight enough. Now, it's not like perfectly straight. It could do something like that. Okay, yeah. This is, yeah, sure, it's straight enough. So this is straight enough. You could say, oh, it has a bend here in the data. Well, it's straight enough. What is straight enough? There's ways inside of JUMP to look at a lack of fit test, but we just kind of look at it and say, yeah, it looks good enough. Why were the other answers incorrect? So this is the only one that's required to make a scatter plot. If you do not have, let's say you have 2 categorical variables, then what would you be making if you had two categorical variables? Great question right there, Lucy. What would you be making if you had two categorical variables? What would you be making if you had two categorical variables? What would you be making if you had two categorical variables? So here's the hint on the screen. What would you be making if you had two categorical variables? Mosaic plot. Yep. And when would you be making a histogram? So this is a good screenshot to get if you're seeing this for the first time. It's got, I think, pretty much all the graphics. You'd make a mosaic plot with two categorical variables. That's the thing I'm on right here. Also contingency tables, stacked bar charts. We don't really use these ones. No worries. This is all practice. Doesn't matter till we get to the test. And then even is a test, whatever. So you can make stacked histograms. I'll have to fly over to it. If you have one categorical and one quantitative, I can't find myself on the screen. Oh, no. I just moved something. Okay, I broke it. Does everyone see these stacked histograms right there? That would be a categorical X and a quantitative Y. And then, Kayla, you're right. One quantitative variable is a histogram. And you see that up there on the top row where there's no X variable. You're just analyzing one Y variable. So just understanding which graphical displays to use and when is very important. QQ straight enough. That means it's generally well described by a straight line. No outliers mean we don't want outliers. And then plot doesn't thicken. Stat 320. You guys want to tell them? I'll give 100 points if in the next 10 seconds we see the word, I don't care how good or bad you spell it, for plot doesn't thicken. Or you can give me the bad word for it. I'll tell you which one's the good word or the bad word. What word do we use in 320? Can you explain the p-value meaning for medians and average test? Oh, we can do that afterwards, Dylan. You got it. We'll do that afterwards. Remind me afterwards. We'll do that afterwards. Heteroscedasticity. So heteroscedasticity, when you have a heteroscedastic relationship, heteroscedastic is going to look something like this. Differing spread, which we know in 201 is what? We're going to earn these 100 points. We got this. 201, you know this as what? You do not want what? QQ, straight enough. No outliers. They know it as heteroscedastic versus homoscedastic, and you know it as the plot does not what? We don't want it to fan. That is correct. Plot does not thicken. Great job, Parker. And so you can see some convergence between the classes. We talk about heteroscedasticity, but if you're talking to someone, you might just say, we don't want the plot to thicken. We do not want it to get worse in its predictions. If you notice this one down here gets worse in its predictions, this one stays steady. And you don't want it to get better. You don't want to see it gets better in its predictions because it gets thinner. Some people have said this one's not. This is a violation. But some people have been like, Brian, this is good because it gets better. You want, as we say in 320, to have homoscedastic, which is the same thickness throughout. So hopefully this makes sense. QQ, straight enough. No outliers. Plot doesn't thicken. And the only one that is required to make a scatter plot is quantitative. You can make a scatter plot if it has bad things, but you have to have two quantitative variables. Great question right there, Lucy. But if the plot doesn't thicken, is the... Oh my God, look at this crazy shakeup of the leaderboard. Cheerful Deer leading the way happily, but Witty Leopard. Never trust a Witty Leopard. They're going to win. Witty Leopard, it's your game to win. True or false? Outliers can make a strong correlation weak. Hint. Anything is something. Someone's got to finish my quote right there. We all know, don't you ever forget, anything is what? Roger, good to have you here. We all know what? Anything is possible. Don't you ever forget, anything is possible. Can outliers make a strong correlation weak? We got a graphic there to show you what's going on. Yes, they can. Outliers can do anything. Outliers can make a strong correlation weak, a weak correlation strong, a positive correlation negative, a negative correlation positive, a correlation of 0 strong, correlation of 0 weak. Well, I guess 0 is already weak, so they can't do that. They can't do what's impossible. Because if the correlation's weak, it's already weak. So I guess they can keep it weak. Well, then it wouldn't be an outlier. Outliers can change correlation dramatically. That's why we say, and they can also change regression. That's why we say QQ straight enough, no outliers, because we don't want the regression or the correlation to be explained by the outlier. So in this graphic, you can see we have a perfect linear correlation, and then we have this point down here, which is drastically impacting it, making it way weaker. So yes, we do not want outliers. That's why we don't want them. Cheerful Deer, you are just, everyone's fighting right there. I'm going for Nimble Lizard this time, though. This is maybe my vote of confidence. Okay, wait, I'm doing it. Ready for this, everyone? I am voting for Cheerful Deer. Cheerful Deer, you've got my vote of confidence. Cheerful Deer is like, no, Brian. Your vote of confidence has been bad this time. Let's find out if it is. Pick the strongest correlation. What's the strongest correlation? I changed. Please tell me I didn't make the mistake on this one. Please tell me. I changed it. I know I changed it. I updated it. And please tell me I did not destroy it. I should never, ever, ever, ever change questions. I'm giving myself a heart attack. Please don't be this one. 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 Woo! I should never change questions. It is the hundredths. And what are the two possible strongest correlations that exist? I scare myself. What are the two strongest correlations that exist? What are the two strongest correlations that exist? 1 and -1. What is the weakest possible correlation? It's all right if you answered this one. Don't worry. You're like, oh, that's the one that's kind of away from the others. So 0 is the weakest. So all that matters. What is the only difference really? I mean, these are basically the same. But what's the difference between these where they're basically the same strength? You're like, well, then why aren't they both correct, Brian? Because one is stronger. They're very close. The direction, great job, Lucy, which is strength, direction, form, unusual features. The direction is very different for them. And this one is technically stronger. It is the right answer. This one's close, but not quite as strong as this one because this one's closer to -1. So pretty good one. I try to put tricky questions on here to catch people and to talk about these key concepts that strength is as close as something is to -1 or +1, and the weakest something can be is 0. So let's see, Cheerful Deer. We can't stop Cheerful Deer. They're going to win. We're going to find out if they're 320 or 201. So we got to do something. We got to vote. We got to go outside the box here. We're voting for Stellar Emu. Look at them just surging to the lead. Stellar Emu, you got this. Only you can stop Cheerful Deer. It's like, I love competition. If the correlation is -0.4, what is r squared? And hint, it wouldn't matter if it was 0.4. This is r squared here we're talking about. It's a complicated formula. R squared. I have no idea how to solve it. As I said, it wouldn't matter if it's -0.4 or 0.4. R squared, known as the coefficient of determination, is the percent of variation in y explained by the variation in x. Basically, it tells us how much of y we understand by knowing x. The higher it is, the better. The lower it is, the less we understand. Lucy's dropping the hints right there. Take r and square it. That is how we get r squared. Now, the big thing is that if this is your r squared, what could correlation be? Now, we're just doing a reverse right here. If this is your r squared, and this is why I have this one up here, if this is your r squared, what could correlation be? If this is your r squared, what could correlation be? If this is your r squared, what could correlation be? Like, if we were to say, we look at this one, and this has an r squared. Sure, r squared of 0.64. What is the correlation of this? Exactly. No, don't worry. Great job, everybody. And Jensen, so good to have you here. I think like someone said, hey, I'm in another class. Can I play? And I'm like, yeah, of course. I'd love it if someone in another class wins. They'd be like, hey, I won. Come play, everyone. Join in. So, and don't worry about tagging me. Mubot, it's all right. They don't have to tag me today, Mubot. I can read the comments. Mubot, you're cool. We love you, Mubot.
I am Mubot.
Mubot, calm down. So, what do we see right here? What is the correlation for this one? What is the correlation for this? This is where usually people make mistakes. What are people thinking the correlation for this one will be? What's the correlation for that one? That graphic there has a correlation of what? Lauren, you're right. You do have, it is one of those two. Lauren, yes. So which one is it though? So everyone make it very clear. And how do you know this? How do you know this? So explain, now we're getting the right answer a lot. Good job right there. This is where we just make sure we see this concept. The slope, the direction, which is the slope. Nice job right there, Lauren. Great work. We're gonna throw another 50 points out. We got a smaller group today, but you know what? The interaction today is really awesome. Lots of great answers, lots of really good practice in remembering strength, direction, form, unusual features, QQ straight enough, no outliers, understanding what these concepts mean and applying them, practicing things like r squared. Very important concepts, and that's what we do on these Kahoots, is we just practice up our knowledge, and I am so glad to have you here. I'm sorry, person. Agile Pony's back. I'm cool with that. Agile Pony, we got this. You're going to win. I don't care that you're 1,000 points behind. You got this. It's like, Brian, why would you say that to me? If someone scores an 85, that's what they actually scored, and we predict they score a 75, what is their residual? I'm like double checking. Please have me selected the right one. I try to correct all my errors. As a whole, what does a straight enough no outliers represent? So straight enough means that the line goes through the data well, and no outliers means that there's no outliers. So it just means that, so what the whole thing means is that regression is appropriate. So if you meet all the conditions, then a regression is appropriate. Like, it's a good idea to do regression. Good job right there. So we've got the formula right up here, the actual minus the predicted. So if someone scores an 85, they actually made an 85, and here's their predicted. The formula for residuals, which, yay, formula. The formula for residuals is, and we did have a notation thing up. I'll have to, no, not Y. E is residual actual minus predicted. And so this is the residual equals the actual minus the predicted. And you'll see some notation on the next few 2 slides to come. Exactly. Lucy, great job right there. They did 10 points better than expected. Lucy, I'm just giving her another 50 points. I really like the interpretation right there. Lucy's 100% right that that's the interpretation. They did 10 points higher than expected. So their residual, they were predicted to make a 75, which means Y hat is 75. Their Y is 85. They actually made an 85. So we can see right here their residual, which is E, is going to be 10. So they scored 10 points higher than expected. So don't think of these as mathematical formulas. Think of them as like concepts like, oh, this person's residual is 10, meaning they scored 10 points higher than they expected. So this person scored 10 points higher than expected. So, hey, as long as we know that. Who's in the lead right here? Cheerful deer. No one can stop cheerful deer. Maybe a joyful seal. Interesting combos right there. Here we go with more residual talk. If a residual is positive, which one was larger? Which one was larger? So the line of prediction is the space pen. I haven't brought back space pen much this semester. I need to bring it back. I'm trying to fix my pen's Microsoft Word. So we have intercept, no. Slope, no. Residual is all about that actual minus predicted. You can see right here that this has a positive residual. These are the actual dots on the screen, the points. This is the line of prediction. All the Y hats are on here. And the actual was higher than the predicted. Sometimes I just double check by making sure I got the answer right, by like doing it while you're doing it. I mean, I wrote the questions. Brian, do you really know how to do stats? I swear, but you know who knows how to do stats? Cheerful deer. This could be close. And remember, first and second get prizes. So this is close. Witty Leopard just jumped into the lead. So did Excited Wildcat. So much excitement, so much craziness. Who's ready for the final question? I need some I'm ready's in the chat. We need some I'm ready's here. It's not Wacky Wednesdays, but we're hitting Wacky Wednesdays. So maybe some people don't get to see Wacky Wednesdays. Lucy's ready. Lauren's ready. Let's do this. We're gonna cut the Kahoot music. We're gonna play some intense music for this last question. Oh man, here we go. Let's do this last question right here. Are you ready? True or false? Adding all the residuals together will sum to 0. Oh my gosh. Happy Kahoot Friday, everyone. People are answering as fast as possible. It's called the line of best fit for some reason. Your kids don't know that this is live. They're like, Mom, can you help out? You're like, no, I have questions, answers, I have stats to do. Yes, it is called the line of best fit for a reason. There are positive and negative residuals. So if you notice right here, some of these go above, some of these go below. Fade out the music. So the line of best fit minimizes the residuals, and all the residuals will sum to 0. That is very, very key right there. So the line of best fit has all the residuals sum up to 0, and it's called the line of best fit, the regression line. 320, we will be covering this next week. Hey, Audrey and Bailey, good to see you here. Audrey, Bailey, I hope you're having a great weekend and getting to enjoy the really nice weather. It's even nice in Texas, but oh, that's awesome. Like, oh. So congrats to the winners. Let's find out who else won. Let's see who won right here. Excited Wildcat. Did everyone think who was it? Deer was in the lead the whole time? Witty Leopard, but you know who's going to be in the lead here. It is Cheerful Deer. Amazing job. 10 out of 10 to all these individuals. Wow. Did they also get 10 out of 10? So tell me if you won. We're doing our usual 1,000 points for first place. You get some big mega points. So let me hop here to space. Time to go to space. Exactly. Congratulations, winners. Congratulations, everybody. Let's bring up Mubot here. I know who's the winners. First through fifth. Lauren. Great job, Lauren. I know I'm like, Lauren, what? No, I'm just like, that is so awesome. Just like, yes. That's like awesome. Email me. Good job, winners. Let's see who won. Let me add the points. Let me put on music here. Let's put on this one. This is my new favorite. Third place, Kayla. Amazing job. 201 getting first. Amazing. Kayla getting third right there, representing 320. Who won second, though? And let me put on... Okay, so we're adding the points in. Got second, Macy. Great job. Macy, we were just emailing. Are you 200 or 320? I'm trying to remember. I know we just like... I just emailed... and please, 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 whenever you're stuck, email me once again. Agile Pony, fourth place. Nice job, Lucy. So, great job, everybody. And thank you, everyone, for giving all the congratulations. Let's just throw another 50 points to the chat today. Hope everyone had some fun with the Kahoot. I'm going to go in and add the points, the 1,000 points for first place. Email me first or second to get your Amazon gift card. And once, two big things. I got two big announcements to end. First place was Lauren. It's like we bet on Kayla. We're like, Kayla's going to win. Great job. And Jensen, awesome job being here. Let's see. Second, Macy. 5,000 points, Macy. Macy, great job on all these points. It's really... I noticed, like, I swear the people who get more points do way better in the class. I'm not even joking. Points is highly correlated with the success because it's correlated with how much you're interacting, how much you're watching. So the more points you have, it doesn't mean you will. There are outliers, but a lot of success I noticed with people getting points. So keep working hard to get, and then I'm adding in everyone's points as we're talking here, and I got two announcements. Once again, wait, I think Lucy, we didn't get Lucy's points yet. We need one more song. We'll put in points. It's like super sad. Lucy, I think you just got to a new level right here. Even before I add in the points, if you hadn't checked your points yet. Correlation does not imply causation. Classic right there. Lucy knows. Also, association does not imply causation. Exactly. You got within the median in 6/8. Nice. Within one standard deviation. Who got fifth place? Remind me who got fifth place. Was it Lucy and I added the points right there? I think Lucy did. So I think I've added everyone's points. Please tell me if I didn't add your points. I'm like double checking. Wait, fifth. I don't know if I got fifth. Do we find out who was fifth? If you're fifth, remind me. And I just added your points, Lucy. So great job right there. I've got two announcements. One announcement, like personal announcement. I didn't want to do this during the Kahoot to be like, hey, let's talk about me. So you may have seen this on LinkedIn. Hop over to the main screen. But we just put out, let me see, copied the link. Good. So we just put out our paper, which is really super exciting to me that we have this going now. We have a paper out. It's got 70 downloads, 190 views. So if you click that link right there, if you're watching this, you can go check out our paper. You can add me on LinkedIn. I thought I was doing my third network. Parker Stevenson got fifth. Awesome. Thank you, Lucy. Let me put up the classes over screen real quick and I'm gonna add the points to Parker. Thank you so much, Lucy. Vols help Vols. I totally missed that Parker said that. And let me add Parker's points in. Parker, we're throwing you 250 points. We're gonna round you up to 5. We're gonna throw a little more. It's easier to round. There we go, Parker. Your points have been added on, and thank you, Lucy, for catching that I didn't add that on right there. Yeah, with MIT, isn't that crazy, Lucy? Dr. Lowe from MIT is absolutely awesome. Like, you should check out the videos he made and he's doing what we're doing. He's making like, I might even show one of his videos. Dr. Lowe is just astounding. I'm thinking, does he have them posted on YouTube? Let me go see if I can get the video. Because Yeah, I never thought I'd be working with someone at MIT, and also just how nice he is. Such a nice person, always helping out. Yep, we can do it here in a moment, Dylan. You got it. So check out this if you want, and I'm just going to show what Dr. Lowe is doing, which is he's using what we're doing. He's there's the World of Aircraft. Let me take this over here. So Andrew Lowe, MIT. Trying to find them. He's got such cool stuff. He's done TED Talk X. That's so cool. Got the TED Talk X coming up in the background. Just, there we go. Man, he does so much stuff. Oh, here we go. Well, that's not his most advanced stuff. I want to show... Wow, just... I'm going to see if I can find it and then we'll head over. Where is it? I might have to go to my emails. Can I find it? Well, give me 10 more seconds here. And if I can't find it, I'm going to head over. Oh, there we go. Okay. It's really cool to see what he's doing. And he's basically advancing what we're doing. Oh, here we go. Almost have it. Yes. Got it. So, as long as he doesn't copyright claim me. Wow, look at that. I don't know, I have not liked this on the Stats 1 YouTube channel yet. This is Dr. Lowe's work right here, what he's doing. You can check out his video. I mean, he's got it looking as professional as we do. He's using a lot of the same technology we are. And so you can see his work, how he's doing the presentation on it, how he's talking in front of it. I mean, like, and he's got awesome graphics. Like, his stuff is top tier. So, and like, yeah, he's got cool graphics. Just, I mean, like, this is how he introduces this. You know how we have our Stats 1 start screen? Like, I have my start screen. Like, this is his start screen. Like, I mean, that's even cooler than ours. Come on. That's awesome. He's got, like, some... Yeah, I love it. So, he's made some really amazing advancements and really great video right here. And so, excellent job. MIT is very lucky to have Dr. Lowe right there doing great, great work. So let's see, Dylan, your question was, are you able to go over the p-values and means? Yeah, which one were you wondering about, Dylan? Let me hop back here to space. Let's see. I know, right? Isn't that cool? Like, and go check out Dr. Lowe's video to already close it down. Check out the paper. Check out the post on LinkedIn. Check out Dr. Lowe's video. I mean, his stuff is pretty... he was one of 2012's Time 100 People of the Year. I mean, that's so... I mean... And he's super nice. Like, not saying you would expect someone not to be nice, but he's just super nice. He's just like, that talks to me. He's like, "Hey Brian, how you doing?" I'm like, "Oh, I'm doing great." And he's like, first few times I talked to him, I was like, "Don't worry." Just, yeah. Anyways, what were you wondering, Dylan, about the p-values? The p-values. Let's talk about some p-values. We'll get back serious here. Let's see. I'm loading up R as we speak. So we have here. We'll load up reg class. Hop over to the main screen. We are back on the main screen. And let's see, I'm trying to find Dylan's original question. Let's see, I'll find Dylan's original question right here while we're... So Dylan, if you want to post, are you able to go over the p-value about means? So, and let me see if I find, because there was another way you asked. I want to make sure I do it correctly here. Think. Can you explain the p-value meaning for the medians and average test for 320? There it is. That was the original. Okay. So when we look at, let's go ahead and load in some data right here. Data survey 10, and that was loaded in from reg class. I think this is task 1. This is task 1 right here. Would we want higher p-value for mean or median because we want central tendency? Well, and so, well, when you look at, let's look at the output. I'm gonna make my life easy. I'm going to go here and go attach and survey 10. And so associate function height tilde gender comma data equals survey 10 and height not found. Oh, because I can't spell. There we go. And so the first thing we look at here is what? What is the first thing we do when we get this output? The very first thing we do when we get this output is do what? Like the first step when we look at this output is we do what? The very first thing when we look at this output is we decide which central tendency to measure, right? The QQ plots, exactly. And so what jumps out to you here, Lucy? What jumps out to you here with the QQ plots? And those are these plots right here. And what jumps, I think that's enough to make a call. Like, yep, great job, Cliff. Excellent work, Cliff. And everyone, good to see you here. And so this jumps out to me immediately, and I'm like, that's a problem. Like, this one's good. I don't see anything major. That one's got a problem right here. And I'm probably going to say it's enough of a problem. It bends at the end, exactly. So we don't want there to be these sorts of bends at the end. That's a big enough problem to me that I'm going to say, I think I'm going with what's. So I think I'm going with what's here. I think I'm going to compare what's between these and usually want to see, yep, and this one looks all right here. This one does not have much of a problem, but if one of them has problems, we usually just say, okay, that's enough to push us over the edge. And so we're going to go with probably medians because there's an issue with this one having too many low outliers. The histogram does show it, but don't look at the histogram. Don't look at the histogram. Don't look at the box plot. We're going to go with the medians. Great job right there, Dylan. We're going to go with the medians. Now we're pretty much done with that output. We can tell what the p-value is from down there, but let's go look at the p-value. Will this produce again? It does. Good. I want the output not to wrap around the screen. I want to see it like this. So when you look at this output on the screen right here, it's important to understand what's going on with these values. Since we're comparing medians, just put this in context right here. The median female was 65 inches tall, which is 5'5". The median male was 72 inches tall, which is 6 feet tall. Now the discrepancy right here is the F statistic, or in truth, the averages one is the F statistic. The medians one is calculated a little bit differently, but it's still the idea of like a ratio of how much variation we observe over how much we expect. So when you think about this right here, we're observing a lot more variation, or about 756 times the variation than we would have expected due to random chance. So there's a lot more variation being observed here than we would have expected due to random chance between the groups. The variation looks to be something that is very unlikely by random chance, 756 times more than we would have expected by random chance. So when we look at the p-value right here, because this one is the test we're going to look at because of the skewed, I just wanted to kind of talk about the F for your assignment, the F statistic there, hint for the assignment. We chose medians because behind my head, we do see some major abnormalities, just so anyone can see again after watching this part. We saw enough to kind of say, let's go medians. So what does this low p-value mean here? That the difference is what? When we look at this, we're talking about the medians, and we're looking at this low p-value, which indicates what? The F is a ratio of 2 chi-squareds technically, and it doesn't really involve standard deviations. I can show you when the F would be very, very small. Here, I'll do this right here. I'm going to make a data set, Lucy, while we talk about this. Let me go here to group, and we'll make a factor, and we'll do this. Whoops. Oh, we'll do this. Rep A 5 times, and then rep B. Let's do this. There we go. And let's go weight is random normal. And random normal is going to come from the 100 sample size with a mean of 170 and a standard deviation of 20. Okay. So it is statistically significant, exactly. These p-values are statistically significant, which means what? What does that mean about the medians here as I type some code up here? What does that mean about the medians when we think about this p-value here being statistically significant? What does that mean about the medians right there? Well, I don't technically need to do that. Sure, I don't need to do that. Associate. What does that mean about the medians? Ooh, that's going to be interesting. I don't want to call it weight again. What does that mean about the medians? That we say this difference right here is found to be statistically significant between the medians. Well, not for practical significance, but more in depth what the statistical significance means. What does the statistical significance mean? So what does the statistical significance mean? I was ready to look for more information on business major analysis. I saw you comment on it. Yeah. Yeah. Hi, ask away. Sure, yeah. Reddit. What is this Reddit you speak of? I'm always willing to answer questions. So what this p-value means down here. Oh, no worries. That's a great answer. I'm not sure is a great answer. Thank you, Lucy, for saying that. Let's just throw some 50 points to the chat. You know I love giving out points, big points on Fridays. I'm not sure is a good answer. What it means is these differences between medians were extremely unlikely by random chance. So the differences we observed between the medians, between the median of 65 and the median of 72, it's very unlikely that this would occur by random chance. And so it might make more sense if we use some data that would be by random chance. So my p-values are below 0.05 conclusive for mean and above 0.05 conclusive for median. But never decide based on, always decide, how do we decide mean or median? How do we decide mean or median? So how do we decide mean or median? How do we decide mean or median? Big thing always, how do we decide mean or median? So we'll never look at p-values to decide mean or median. We'll always decide mean or median how. Mean or median's always decided how. Because we don't QQ plots, exactly. So never decide based on the p-values or the conclusivity of intervals. You'll always base it on the data. And so this data right here, let's look at this data. This data, wait, what is it? Oh, ha. Okay, this data right here, means or medians. This data right here, means or median. Yep, and then, so always look at the QQ plots. And so for this one, means or medians. And so which one we use here, means or medians? So look at the QQ plots. The normal quantile plots or the normal probability plots, the means. This one's definitely means. There's nothing even that goes outside of our kind of like meh range. So you can have little variation at the end, hint for yours. You can have things that are a little bit bad, but you always want to make it clear, like make your case. Like the stronger, like you could get counted off on your assignment, but if you make a strong enough case, I might be like, well, I'll give the points back. But if you're like, if you answer to this, like if you say, I looked at the QQ plots and I should use medians, one, I don't think there's any way to argue for medians on this one, but you would have to like say like, at this point, we're deviating from normality. Like you should make a good argument, even for means. My argument for means is looking at the QQ plot, all the points are within the bounds of what we would expect the normal distribution to be. We do not see any deviations, even though there is a small outlier on the B distribution. That B point is the tiniest bit outside of bounds of what we would expect for the normal curve. So yes, I do think we should be using means here because pretty much all points, save 1 point, as far as I can tell, fits what we would expect via the normal distribution to be. Yeah, and these points were actually generated via a random normal, so they actually are normal. Now, so these points all come from one group, Lucy. Like everything with this weight 2 are weights that are all from one group. So do you think the p-value here will be large or small? Do you think the p-value here will be large or small? And I'm going to cheat because yeah, that looks better. Do you think the p-value here will be large or small? The previous one was a little bit somethinger than what I wanted by random chance, which can happen by random chance. All these weights are coming from one group right here because it's just the weights are just random at all times with a mean of 170 and a standard deviation of 20. It'll be a very large p-value. And the previous output had a large-ish p-value. You see, they're kind of smaller. I don't like that. But in the second example I made, it's a judgment call, but make sure it's clear why you're doing it. Like, there's bad QQ plots. Like, watch this. There's obvious cases, like this right here. If these were your Q, did I not change it? Oh, did I click twice? Oh, random exponential doesn't have the arguments. Cool. It's mad at me. If this was your QQ plots, the answer should be also, yeah. Let's do more points. Oh, we can't. Oh, we'd have to do this then. Now it'll be more obvious. Yeah, that's way more obvious with more points. If these are your QQ plots, there's no way you have to use what? Yeah, you got to explain your reasoning. Great job, Lucy, right there. That's the big thing. And if these are your QQ plots, you'd have to use what? Like, anyway, I would tell you crazy if you try to use the other thing. You have to use what if this is your QQ plots. You don't have to, but I mean, I'll count points off if you use the other thing. This is a median, so this is 100% medians. So when you have the p-values, so that's the key thing, and that's what we were talking about, Dylan. That's what we were talking about a moment ago. When you have the p-values here, what does it mean? You're talking about these p-values right here. So when you look at these groups right here, so we'll put this back to a random normal, so it's more like real data. 1,000 points, mean of 170, and standard deviation of 20. So when you have this p-value here that's very, very high, what does this mean? This p-value here that is very, very high for means, I don't like it being that low. I want it to be higher, and it's supposed to be. It's by random chance, because it is by random chance this time. This p-value here that's pretty high, what does that mean? What does it mean that this p-value here is pretty high? That this p-value, we have an F ratio of 1.339, meaning that the differences we observed between groups was about 1.3 times larger than we would have expected due to random chance, given that there is no differences between the groups. So we observed a difference that was 1 point, hint for your assignment, we observed a difference that was 1.3 times larger than what we would have expected via random chance, which is not that much bigger. Yeah, it's in Lucy, great word that right there, likely, not that it is by random chance, it's just likely. That's what because when we think about a p-value, it's a probability. So we think, yep, yeah, right there. These differences are likely by random chance. Now look what I've done here. Do you see the box plots and how the box plots are very close to each other? Now watch my box plots. Watch this graphic right here. Watch the box plot. Don't move your eyes off these box plots. Now look at the differences between the groups. Now these differences between the groups, which are much larger, are probably what? These differences between the groups, before the groups were pretty lined up, now that groups are pretty far apart, these differences between the groups that are quite a bit larger are probably going to be what? These are larger differences between the groups. And you can see the p-values behind me if you look. You can actually tell what all the p-values are. These differences between the groups are going to be what? You know what's really interesting? Look at here in just a second. These differences are going to be basically impossible by random chance. And I think that normal curve deviates a little bit. Do you see this down here? This is why, and this is super important for your assignment too. This data that I'm generating, Lucy and everyone else, this data I'm generating is all coming from the normal curve. Every one of these values are all from the normal curve. Like this is actual normal data. And then I want you to take a look at this QQ plot. And do you see how it has some error right here, like it's outside, and this one goes outside here? This is why we're forgiving, because this data we're generating, does that make sense, Lucy? This data is actually normal data. I'm using normal data. We're deciding if we should use the mean, which is based on normal data, and we do see some deviation here, a little bit of deviation. We see some deviation more here, but that's why we're usually pretty forgiving on it, being like, it's not that bad. We want to see things that are more, yeah, exactly. So this is normal data. Like I am generating random normal data, and sometimes random normal data can look a little bit bad. Now this one might not look as bad. Oh, look, down here you got a deviation. This one looks better, but down here you have some deviation off the normal curve, and this is, once again, normal data. This is all normal data that we're using right here. So we are using normal data. Well, you might not be using normal data. For this example, I am generating random, this stands for random normal. So when you type R normal, it can generate like 100 z-scores, but I could say, let's generate test scores with a mean of 80 and a standard deviation of 10, and it'll generate random test scores or random whatevers. So R normal, or you can make exponential numbers, random exponential numbers. There's 100 random exponential numbers. So it's a really good way. Yeah, those are cool little codes right there that I really like, that whenever I want to create random numbers, I just use those codes. Does that make more sense looking at this output and understanding what the p-values are? Yeah, not necessary for the assignment. It's a good thing. Generating random numbers is good. You can also generate random numbers if you want to flip a coin. Well, flipping a coin, you can just say sample heads and tails. So, probably a better way is going to be this. Do this right, coin, queen, save into coin, heads, save into coin, tails, and then go right here and say sample coin 1. So heads or tails, heads or tails. You can flip a coin now. You're like, let's flip a coin. There go tails. Coin came up tails. You could flip a coin 1,000 times if you wanted. Awesome, Dylan. Glad to hear that. So, you know what's interesting? You could find out how... I might even do this real quick. Tails, great. You got it, Lucy. Nice job. Here's 1,000 flips. You know what we could do? If you'd have to take this vector. If... Let's do this. If... No, we have to do a for loop. Yeah, if... Oh, wait. I think I can figure this out. I want to write a coder here. I know, right? Yeah. How often do you... What do you think is the longest run of... what's the longest run of heads or tails you can get in a row, do you think? Like, what's the... With a 10,000 flips, what's the longest run of heads or tails you would get? Like, do you think you'd get 8 heads in a row, 8 tails in a row, or maybe 10 tails in a row? I think I can write in a code to figure this out, and we could do a simulation. This is like brute force simulations right here to figure these things out. So if flips position 1 is equal to flips position 2, is going to return a true or false. If that's equal to true right there, oh man, this would be really hard to write. So it is true. Our first 2 flips were the same flips, at least in this sequence. Yeah, those are equal right there. Then you could put here true. You could save. So let's put here check. Let's put here check vector. And check will be a blank vector. Then store into check position 1. Store into that true. Else store into that. Else store into check position 1 false. There we go. And that's just store into check. Got it. For loop time, for loop. This is Brian having fun. Start off here at that. I plus 1, I, and variable I, that's my placeholder. And we're starting at 1 and going to 9999. Okay, got it. And let's look at check. There we go right there. And we'd look at the longest sequence now. Whoa. We actually started off with a lot of the same thing. That's crazy. I didn't know that. On this sequence, we had... Whoa. Yeah, look at this. This was random right here. Tails 2, 3, 4, 5, 6. We started off with 6 tails in a row. And then we went 1, 2, 3, 4, 5, 6. So I'm trying to think of a way to turn this now into what's the longest sequence. Okay, let me try. I think I can do one more code right here. So this is the check right here. Okay, I think I know how to do it. If check position I equals check position I plus 1, then save into count. I don't think I've called anything count yet. If I did, I just deleted it. Then save into count. Let's see here. It'd be... No, it's not going to do it. Then save into count. We might actually need to do this. Count position 1 is equal to 1. If save into count position, this is going to start off at 1. If it's equal to it, then save into it. Count position 1 plus... No, okay. So we need to start off on 2 here. It's less. And plus... Nah, my code's gonna... I'll just see what it does. Else start the count over. That's not the right code. Yeah, that's not the right code. It's probably a much easier way. I stumped myself. I need to like make my code look better too. So I stumped myself right here. But I'll take a look at this. I'm just trying to count like how many, all this right here. I know we almost went full on hacker mode, man. Almost did it today. So close. I'll take a look at it. I was just trying to figure out the max number. It seems like an if. Could be done with a while. She needs to go here and look at this, and then look at the next one. Wait. While flips. Oh my gosh, might be able to do it. I think I figured it out. While it's just had to turn on hacker mode. Got to go full 80s. Okay. While flips position I is equal to flips position J. Then go here to max a row. And add to it 1. So max row plus 1. And okay. So we need a counter here on I. So I is going to start off at 1. J is going to start off at 1 or 2. And then J I need to put in a for loop then. Oh man. And we need to say while. Okay, wait. Then we go here. This is like me having fun. This is sad. While I is less than or equal to 10,000, run this loop right here. Okay, good. While it's going to keep doing it while I is less than or equal to that. So now it's going to see, like, this is my fun. Let me turn off the 80 static. So it's going to do this, the max here. And it's going to overwrite it every time, though. And then when it leaves this, max a row, and let's call this how many position, how many first time, so HJK. And so K needs to start off at 1. And then K will increase right here each time. So that way we get a new K position. And it's going to loop back through. I've almost done this. I've almost got this. I think I'm thinking it through. So now I is going to stay the same. Here's where I increases. So here I is going to go to J plus 1. And here J goes to J save into J plus 1. I've got something theoretically wrong. Something tells me in my head. Oh, it's doing something. I think I made an infinite while loop, though. That looks like an infinite while loop. Is I not increasing? That's an infinite while loop. I know an infinite while loop when I see it. Well, and nothing got stored. Numeric 0. Make it small, little bits. Everyone knows. Little bits. Well, with that, I will check this out. I'll keep working on it. I almost got to what I wanted. There's got to be an easier way. There's got to be a much easier way. I'll figure it out. Lucy, email me. Everyone, we will see you later. Let's hop back here to space music. It is time to head off. Email me if you have questions. I will talk to everyone later. Bye for now, everyone. Bye. Bye, Mubot.
I am Mubot.
Oh, question. Hi, asks, computer science versus business analytics. It's a broad degree. I'm stuck with one occupation. Is it easier to land a job right now after college? Is it competitive? The biggest thing, one. No, don't worry. Hi, I'm back for the moment. Because I forgot we had the question about that. And feel free whenever I'm just goofing off like that, just feel free. Hey, Brian, I got a question. One, major in what you love. Talk to people who have your degree, find out what they're doing, shadow somebody, intern with somebody, major in what you love. I can't state that enough. Yes, worry about employment. Worry about, am I going to make a good salary? Those are good things to worry about, but don't do something because you're like, I'll get employed with this, and I probably will get employed with this. Computer science and business analytics right now have really good employment rates, but the bigger thing is the skills you get. If you come out in either major and you're not focusing on skill sets and focusing on connections, it's very hard to get a job. So just think about this. Would you want to be, I'll give you a choice. You can be the best computer science major or the worst business analytics major. Which one do you want to be? You say, well, the best computer science major. You can be the best business analytics major or the worst computer science major. You want to be the best business analytics major. So the better you are in your field, the more opportunities you have. And just focus on that. Focus on because both have great opportunities. Like computer science, awesome degree. Computer science, engineering, business analytics, marketing, economics, finance. There's so many great degrees out there. I really personally, see me say it on Reddit, I love all the Haslam College of Business degrees. I think they're excellent. I think it's just choosing what's best for you. But don't think of that the degree will get you a job, and don't think that a certain major will get you a job. Realize that your job opportunities are going to be majorly in part due to who do you know, and that's not just I know this person because my family or something, but when Haslam has job fairs, when Haslam has employer of the day, go talk to the people at the job fair. Go talk to the employers of the day. We had, real quick story right here. Put on another song here. We had Pepsi come and visit last semester, and I'm going to reach out to Pepsi. That's too sad for Pepsi right there. I'm going to reach out to Pepsi and ask them if they want to come and visit again, because it'd be really great. They hired an intern from that meeting. So maybe if we have Pepsi come and visit again, we'll have another student get an internship, and I think that's a great opportunity. So it could just be going to class that gets you an internship opportunity that then leads to a job. And we do have the data to say that people who get internships are likely to get jobs, more likely, not just likely. But so hi, good question right there. And the hardest part for me for answering that for you is that I can't answer it for you. Is that it's going to come down to, if you really love computer science, then get to know as many people as you can in that department and experience what the job market's like and experience what the job would be like by shadowing and talking to people. If you really love business analytics, get to know everyone in our department. You don't have to know everybody, but get to know people in our department and get to know what the job opportunities are like and see if it's right for you. And I'm more than happy to talk to you about business analytics and why I love it. But that it's all right if you don't love business analytics. That's not for you. You know to love something. You don't have to love computer science. I like video games more than I like business analytics. Sorry, business analytics. Video games are cooler. With that, does that help out Hi? Does that help out any? I hope I didn't just say, do what's best for you. Awesome. I'm glad that helps a lot. And I'm more than happy to answer any questions you have. And I think I know some people in the computer science department, but I want you to find what you love. I want you to be excited about it. And with that, we are off for now. Second time, everybody. Bye for now. Bye. Don't feel any pressure. We'll talk through it. You got it, Hi. Feel free to ask me any questions you want.